We have mapped the mountains of Mars. We have photographed the rings of Saturn. We have stood on the very roof of our world. But there is a frontier, right here on Earth, more alien and unexplored than any of those places. It begins where the last shimmer of sunlight vanishes, crushed by an impossible weight. This is not a story about the ocean we know. This is a story about the ocean we don't. A world of perpetual midnight, of crushing pressure, and of living light. Down here, in the deep, the rules of life as we know them are rewritten, and what we are only just beginning to discover is changing everything we thought we knew about our own planet, and maybe even life itself. Picture this. You are sinking. The warm, sun-dappled blue of the surface world fades to a cool, gentle azure. The world gets quieter, heavier. At about 650 feet down, you cross an invisible, momentous line. You have entered the twilight zone, the mesopelagi. This is where the last traces of sunlight, just 1% of the surface light, fade into a permanent, dusky gloom. This is the ocean's great secret borderland. Above, life is fueled by the sun. Down here, a new, stranger economy takes over, an economy of shadows, of sinking scraps, and of stolen light. This is the first act of the deep-sea drama, and it's packed with more life than we ever imagined. We used to think this zone was a barren highway, a mere passage to the depths below. We were dead wrong. It's a bustling, thriving metropolis of creatures who have mastered the art of invisibility. Many are transparent, like living glass, ghosts in the twilight. Others are painted in the deepest reds and black colors that, in this blue-lit world, simply vanish, turning them into silhouettes against nothing. And here's where the magic, the literal, biological magic begins. From this fading light, life makes its own. This is the realm of bioluminescence. Living light is the most common form of communication on the planet, and yet, until recently, it was happening almost entirely out of our sight. Think about that for a second. We talk about the internet, about radio waves, about a connected world. But for eons, the deep sea has been a vast, silent network of flashing codes and glowing signals. A firefly show of staggering proportions happening in total darkness. Jellyfish pulse with soft, blue galaxies. Shrimp eject clouds of sparkling, distracting light, like underwater fireworks. But this isn't just for pretty displays. This is a matter of life and death, of hunting and hiding, written in flashes and glows. Which brings us to one of the twilight's most fearsome and fascinating residents, the dragonfish. Now this creature looks like it swam straight out of a nightmare, and in a way it did a very old, very successful nightmare. It's a long, slender predator, with a jaw full of needle-like teeth so huge it can't even close its mouth properly. But his real secret weapon isn't those terrifying teeth. It's a light, a single, small, red photophore, or light organ, just beneath its eye. Here's the crazy cool part. Most deep-sea creatures can only see blue and green light, the colors that travel farthest in water. They are blind to red light. It's like their world is in black and white. But the dragoonfish has built a sniper scope. It produces its own red beam, a private, invisible hunting light. It can illuminate its prey in a glow that only it can see. To a shrimp or a smaller fish, it's just swimming in darkness. But to the dragonfish, that prey is spotlighted, clear as day. This is stealth technology perfected over millions of years. It's like having night vision goggles when everyone else is blindfolded. But the twilight zone is just the antechamber, the waiting room. Keep sinking. The pressure builds, a feeling of being squeezed from all sides. The temperature drops near freezing. The last hints of blue vanish, eaten by the sheer volume of water above you. At about 3,300 feet, you leave the twilight behind and enter the true, eternal night. This is the bathypelagic zone, the midnight zone. The pressure here is over 100 times that of the surface. It would crush a submarine not built for it. And yet, life not only exists here, it thrives in ways that defy belief. The creatures here are the stuff of pure legend. The giant squid, no longer a myth, but a documented, elusive reality. The gulper eel, with a mouth like a gigantic, delicate net, and a body that seems like an afterthought. The anglerfish, the famous femme fatale of the deep, with a bioluminescent lure dangling from her forehead. A fishing rod of living flesh in the blackness. This is a world of extreme scarcity. No plants grow. No sunlight fuels a food chain. Everything here depends on the marine snow. A constant, gentle shower of decaying matter, dead plankton, animal waste, and dust that drifts down from the world above. It's a cosmic slow-motion rain of detritus that has fed entire ecosystems for millennia. The creatures here are masters of energy conservation. They move slowly, deliberately. They have evolved elastic stomachs and expandable bodies to engulf any meal, no matter how large, because you never know when the next one will drift by. It's a world of patience, of incredible efficiency, and of spectacular, gruesome adaptations. Sink deeper still, past 13,000 feet. You are now on the abyssal plain. This is the planet's dominant landscape. Think about that. The The single most common physical environment on Earth is not forest, or desert, or grassland. It is this, a cold, dark, muddy plain that stretches for millions of square miles across the ocean floor. It is a landscape of profound stillness, buried under miles of water. The pressure is crushing, upwards of 500 times surface pressure. And yet, when our specialized submersibles and remote robots finally reached these plains, they made a discovery that flipped biology on its head. We found life not just surviving, but thriving, in places we thought were sterile. We found it not just in the mud, but under it. The wildest discovery on the abyssal plain didn't involve a terrifying monster. It involved a rock, and a crack, and a whole new way to live. This is the world of hydrothermal vents. These are geysers on the ocean floor, where superheated water, rich in minerals, spews from the Earth's crust. The water can be over 700 degrees Fahrenheit, but it doesn't boil because of the immense pressure. It's a toxic chemical soup. And around these vents, in total darkness, cut off from the sun's energy, we found lush, bustling oases of life, giant tube worms, 10 feet tall, clad in white chitin, waving in the hot currents, clams the size of dinner plates, blind shrimp by the thousands. This ecosystem runs not on photosynthesis, but on chemosynthesis. Bacteria inside these animals convert the toxic chemicals like hydrogen sulfide into energy, where the way plants convert sunlight. This was the wow moment that changed everything. It proved that life could build a world entirely independent of the sun. It redefined the conditions for life, opening our minds to the possibility of life on ice-covered moons like Europa or Enceladus, where similar chemical-rich oceans might exist under the ice. The discovery of vent life was like finding a hidden, thriving city in the middle of the Sahara, powered not by the sun, but by the desert itself. And then there are the cold seeps, slower, cooler cousins of the vents, where methane and other hydrocarbons leak from the seafloor. Here, life has done something equally mind-blowing. It has formed a partnership. Bacteria and archaea that eat methane form mats on the seafloor, and other creatures, like the yeti crab or fuzzy white crab that looks like it's wearing a shaggy coat, farm these bacteria on their own claws, grazing on the energy source they cultivate. This is agriculture, happening 2 miles beneath the waves. So how do we explore this impossible world? The story of deep-sea exploration is a story of human ingenuity facing the ultimate pressure test. For most of history, the deep was a blank space on the map, filled with monsters of the imagination. The first breakthroughs were heroic acts of engineering and bravery. The bathysphere, the Alvin submersible, which famously helped explore the Titanic and the hydrothermal vents. These were metal spheres protecting fragile human bodies from the crushing force. Today, the explorers are often robots, remotely operated vehicles, or ROVs, tethered to ships above. With robotic arms and high-definition cameras, are our eyes and hands in the deep. Autonomous underwater vehicles, or AUVs, roam free like underwater drones, mapping vast swaths of the seafloor with sonar. We are no longer just visitors. We are becoming residents of the deep, through our machines. We have mapped more of the surface of Mars than we have of our own ocean floor. That fact alone should give us pause. We are, in a very real sense, still discovering our own home. And what we are finding is rewriting the textbooks every single day. We are discovering species at a staggering rate, thousands of new life forms every year. From microscopic microbes to colossal squids. We are finding that bioluminescence is even more complex than we thought, with some creatures using polarized light, a visual trick we can barely comprehend. We are learning that the deep sea is not a silent world, but a surprisingly noisy one, filled with the clicks of sperm whales, the rumbling of earthquakes, and the songs of fish we have yet to identify. We are also discovering that the deep ocean is the planet's great thermostat and carbon sink, playing a silent, critical role in regulating our climate. The life down there is part of a vast, slow-moving biological pump, moving carbon from the atmosphere to the seafloor, where it can be locked away for millennia. But with discovery comes a new and urgent responsibility, because this alien world, for all its mystery, is deeply connected to our own, and it is under threat. The future of the deep is at a crossroads, and the path we choose will be written in the coming decades. The first major trend is the march of technology itself. The next generation of explorers won't just be in bulky submersibles. We're developing soft robotics, flexible, nimble machines that can squeeze into delicate vent communities or coral gardens without damaging them. We're creating swarms of tiny, cheap sensor AUVs that will blanket an area, giving us a real-time, high-definition picture of deep-sea life like never before. Artificial intelligence is being trained to identify species on the fly, analyze behaviors, and even guide robots to the most interesting discoveries autonomously. We are building a persistent, intelligent presence in the deep. The second, and more troubling trend, is the encroachment of human activity. The deep sea is no longer a sanctuary. We are fishing deeper and deeper, dragging nets across ancient, slow-growing coral forests that take centuries to recover. We are considering mining the abyssal plains for rare minerals like cobalt and manganese, used in our smartphones and electric car batteries. The thought of giant underwater tractors scraping up the seafloor is no longer science fiction. It's a looming industrial reality. The noise pollution from ships and industry is flooding into the deep, potentially disrupting the communication and navigation of creatures who have relied on a quiet world for millions of years. And even our climate change warming and acidifying the surface ocean is sending shockwaves down into the depths, altering currents and oxygen levels. The creatures of the deep, evolved for a stable, cold, dark environment, may be some of the most vulnerable to these rapid changes. This presents us with a profound and urgent choice. Will the deep sea become the next frontier for resource extraction, a new Wild West with untold consequences? Or will we choose to see it as the largest museum of natural history, the greatest biological laboratory, and the most important climate regulator on the planet, common heritage to be protected with fierce, international wisdom? The answer isn't clear, but the direction we are leaning in will define this hidden world's fate. Imagine a near future where we have permanent monitoring stations at hydrothermal vents, streaming live video of tube worm colonies and alien crabs to classrooms and living rooms around the world. Imagine discovering not just new species, but new biochemical compounds in deep-sea life that could lead to breakthrough medicines, naval antibiotics from sponges, cancer treatments from tunicates. The deep sea is a treasure trove of genetic innovation, a library of solutions to problems we haven't even faced yet. But we can only read those books if we don't burn the library down first. We began this journey at the edge of the light. We have traveled down through the twilight, through the midnight, through the plains of the abyss. We have met creatures of living glass and living light, hunters with invisible beams, and ecosystems powered by the Earth's own fiery heart. The deep ocean is the final, great, wild place on Earth. It is a world that forces humility. It shows us that life is far more creative, resilient, and bizarre than we ever dreamed. It reminds us that we know so little about the very planet that gave us birth. So, the next time you stand on a beach and look out at the vast, blue horizon, remember what lies beneath. That peaceful, rolling surface is just the skin, the covering over a reality so vast and strange it dwarfs our imagination. The real adventure isn't out there among the stars. Not yet. The real adventure is straight down, into the dark, into the pressure, into the living, breathing, glowing heart of our own, still watery world. The question is no longer what is down there. The question, now, is what will we do with the wonders we find? Will we be wise stewards, or will we be the monsters that the deep finally had to fear? The answer is still sinking.